The world of project management is in a constant state of flux, a dynamic field that is perpetually reshaped by the powerful currents of global change, technological advancement, and societal evolution. In this 21st century landscape, the role of the project manager has transformed far beyond the traditional remit of simply delivering a product on time and within budget. Today's practitioners are required to be master navigators, steering their projects through an intricate web of emerging challenges and unprecedented opportunities. They must contend with issues that were barely conceivable a generation ago, demanding a new level of strategic thinking, adaptability, and leadership to achieve success in this complex modern environment. A primary driver of this transformation is the relentless march of globalization. Projects are no longer confined to a single office, city, or even country. They frequently span multiple time zones, diverse cultures, and a variety of languages. This necessitates a sophisticated approach to leadership. Project managers must become experts in virtual communication, capable of fostering unity among team members who may never meet in person. They must also navigate international regulations, fluctuating exchange rates, and global supply chains, where a disruption on one side of the world can have immediate consequences on the other. Simultaneously, the accelerating pace of technological change presents both challenge and opportunity. Innovations in artificial intelligence, machine learning, automation, and advanced data analytics are revolutionizing how projects are planned, executed, and monitored. However, this technological wave is a double-edged sword. It often gives rise to projects with extreme technical uncertainty, where the path to the final solution is not clearly defined at the outset. Furthermore, it demands entirely new skill sets from project teams, placing a premium on digital literacy and working alongside intelligent systems. Beyond the technical and geographical shifts, a profound change in societal expectations is reshaping the definition of project success. There is a growing demand for projects to be more than just economically viable. They must also be environmentally sustainable and socially responsible. The principles of environmental, social, and governance, or ESG, are becoming central to project selection and planning. This requires measuring success not just by the traditional metrics of scope, time, and cost, but by the project's long-term impact on the planet and its communities. This educational material has been meticulously designed to serve as your comprehensive guide through the intricate world of modern project management. Its primary purpose is to equip you with a rigorous and profound understanding of the core principles, essential tools, and proven best practices that define this critical discipline. Upon diligent completion of this study, you will not only be familiar with the terminology, but will also possess the confidence and competence to apply this knowledge in practical, real-world scenarios, transforming you from a passive learner into an active and capable practitioner of the craft. One of the foundational objectives of this guide is to ensure you can understand and articulate the fundamental concepts that form the bedrock of project management. This includes a deep dive into the specific language of the profession, from stakeholders and deliverables to risks and milestones. You will learn to distinguish between different project life cycles, understanding when a predictive, plan-driven approach is appropriate and when an adaptive, iterative model is required. You will learn how to deconstruct complex undertakings into manageable components using a work breakdown structure. We will guide you through the creation and interpretation of network diagrams, such as PERT and CPA, to identify the critical path and manage project timelines effectively. You will also gain proficiency in resource scheduling and allocation, learning how to balance the demands of the project with the availability of people, equipment, and materials to create a realistic and achievable plan. Finally, a central aim of this material is to prepare you to lead and manage project teams with confidence and effectiveness. We recognize that projects are ultimately delivered by people, and understanding human and organizational dynamics is paramount. This guide will explore different organizational structures and their impact on project authority and communication. By understanding these human elements, you will be equipped not just to manage tasks, but to inspire collaboration, foster a positive and productive team culture, and guide your team to achieve its collective goals, making you a true project leader. To truly comprehend the vast and vital discipline of project management, we must first establish a clear and precise definition of its most fundamental unit, the project. The Project Management Institute, or PMI, a globally recognized authority in the field, provides an elegant and powerful definition. It states that a project is a temporary endeavor undertaken to create a unique product, service, or result. This seemingly simple sentence is built upon two foundational concepts that distinguish project work from all other forms of business activity. The first cornerstone of this definition is the concept of being temporary. This characteristic implies that every single project, without exception, has a discrete and definable beginning and a discrete and definable end. This finite nature stands in stark contrast to the world of operations, which represents the ongoing, repetitive, and permanent functions of an enterprise. Operations maintain the organization, while projects are the engines that change it. The second cornerstone is the concept of being unique. The output of any project must be a unique, identifiable deliverable that has not been created in exactly the same way before. This uniqueness can manifest in a multitude of forms. Even in cases that appear repetitive, such as the construction of houses in a large development, each house is a unique project due to differing ground conditions, specific customer customizations, or slight variations in materials. This inherent uniqueness is a primary source of uncertainty and risk, making careful management essential. Building directly upon this definition, we can now define project management itself. It is the strategic and deliberate application of specific knowledge, specialized skills, powerful tools, and proven techniques to the full range of project activities. Historically, these constraints have been defined as the triple constraint, or iron triangle. Scope: what work must be done? Time: what is the project schedule? And cost: what is the project budget? The model posits that these three constraints are interdependent. A change in one will inevitably impact at least one of the others. For instance, reducing the project's timeline might require adding more resources, increasing cost, or reducing the features to be delivered, reducing scope. To fully appreciate the role of project management, it is essential to place it within its broader strategic context. Program management and portfolio management. Portfolio management focuses on ensuring the organization is undertaking the right projects and programs, those that align with its strategic goals and provide the maximum value. It is the bridge between strategy and execution. A particularly useful and insightful way to conceptualize a project is to view it as a conversion process. This model encourages us to see the project not as a chaotic series of tasks, but as an organized and purposeful system. Inputs: these are the resources required to undertake the project. They include capital, materials, equipment, facilities, information, and most importantly, human resources, the project team. The conversion process. This is the black box where the work of the project happens. It encompasses the planning, executing, and controlling activities, the application of tools and techniques to coordinate the inputs and create the outputs. This is the domain of the project manager. Outputs. These are the direct, tangible results or deliverables of the project. This could be a finished software application, a constructed bridge, a completed research report, or a newly implemented business process. The project's success is primarily judged by the quality and acceptance of these outputs. No project exists in a vacuum. It is constantly influenced by its environment, which can be broken down into two main categories: the internal, organizational environment and the external environment. Internal organizational environment. These are factors within the organization undertaking the project. They include the organization's culture, structure, political climate, available resources, and existing systems and processes. A project manager must be adept at navigating this internal landscape. External environment. These are factors outside the organization that can impact the project. They include the economic climate, legal and regulatory frameworks, technological trends, market conditions, social attitudes, and the physical environment. A successful project manager must monitor these external factors to identify potential opportunities and threats. Projects vary enormously in their level of complexity. Understanding the sources of complexity is crucial for selecting the right management approach. Key dimensions of complexity include structural complexity. Relates to the scale of the project, the number of distinct elements, tasks, and interdependencies. A project with thousands of tasks and hundreds of stakeholders is inherently more complex to coordinate than one with a dozen tasks. Technical complexity arises from the level of novelty, uncertainty, and technological sophistication involved. A project to develop a first-of-its-kind pharmaceutical drug is more technically complex than building a standard residential home. Directional complexity pertains to the level of agreement and clarity on the project's goals and methods. When stakeholders have conflicting objectives, or there is ambiguity about the desired outcome, directional complexity is high. While the practice of coordinating complex temporary endeavors is ancient, evidenced by the pyramids of Giza and the Roman aqueducts, the codification of project management as a distinct management discipline is a 20th century phenomenon. The intellectual groundwork was laid by thinkers like Henry Gantt, who in the 1910s developed the revolutionary Gantt chart. This bar chart was the first major tool to visualize a project schedule against a timeline. It remains a cornerstone of project management today. The discipline matured rapidly during the 1950s, driven by the scale and complexity of large government and military projects. Two seminal scheduling techniques emerged. The critical path method, CPM, developed in the late 1950s. CPM is a deterministic model that uses a network diagram to identify the sequence of stages determining the minimum time needed for an operation. Program Evaluation and Review Technique, PERT, developed concurrently by the US Navy for its Polaris nuclear submarine program. PERT is a probabilistic model designed to manage projects with high degrees of uncertainty in activity durations. Late 20th century, professionalization and codification. The establishment of professional bodies marked the discipline's coming of age. The Project Management Institute, PMI, was founded in the US in 1969. These bodies began to create standardized terminologies, ethics, and bodies of knowledge. Most notably PMI's A Guide to the Project Management Body of Knowledge, PMBOK Registered Trademark Guide, first published in 1996. This professionalization provided a common language and framework for practitioners worldwide. The concept of continuous improvement is fundamental to mature project management. This principle is formalized through the Plan, Do, Check, Act (PDCA) cycle. Plan, identify an opportunity and plan for a change. Do, implement the change on a small scale. Check, use data to analyze the results. Act, if the change was successful, implement it on a wider scale. A critical component of this cycle in a project context is the formal process of capturing lessons learned. This is a conscious effort to document what went right, what went wrong, and why. This knowledge, when stored in an accessible organizational repository, becomes an invaluable asset, preventing future project teams from repeating past mistakes and institutionalizing successful practices. Without this reflective loop, an organization is destined to solve the same problems over and over again. AI and data-driven project management. The role of artificial intelligence is evolving from a passive assistant to an active partner. AI-powered systems will perform predictive analysis on project risks, optimize complex resource schedules in real time, and automate routine status reporting. This elevates the project manager's role from a data collector to a strategic decision maker, requiring skills in data analytics and interpretation. The rise of hybrid methodologies. The ideological battle between waterfall and agile is giving way to a pragmatic synthesis. The future PM will be a methodological chameleon, blending approaches to fit the project's unique risk profile. Intensified focus on value and benefits. Realization. It is no longer sufficient for a project to be delivered on time and on budget. Stakeholders now demand demonstrable value, ensuring that the intended strategic benefits are actually achieved and measured long after the project's conclusion. The primacy of organizational change management, OCM. There is a growing recognition that even a technically perfect project deliverable is a failure if the organization does not adopt it. OCM, which involves managing the human side of change, is becoming a core competency for project managers. They must be skilled in communication, stakeholder engagement, and training to overcome resistance and ensure the project's output is successfully integrated into the organization's daily operations. The Channel Tunnel, CHUNNEL, stands as a monumental achievement of engineering and a sobering lesson in the governance of mega-projects. Context: a politically and financially complex binational infrastructure project. Its scale was unprecedented, involving the development of new tunnel boring technology and complex railway systems. Key challenges: governance and stakeholder complexity. The project structure involved a web of competing interests. Aligning these stakeholders was a Herculean task. Optimism bias in estimation. The initial budget of £4.8 billion was a dramatic underestimate. The final cost ballooned to over £10 billion, nearly bankrupting the project. Lesson: the Channel is a powerful case study in the distinction between project success, the tunnel was a technical marvel, and project management success. The project failed catastrophically on its cost and time objectives. It underscores that for mega projects, robust governance, realistic forecasting, and transparent stakeholder management are as critical as the engineering itself. This case study illustrates the unique challenges of a business process change project, where success is measured by adoption and cultural shift rather than a physical artifact. Context: implementing a formal quality management system like ISO 9000 in a public healthcare setting aims to standardize clinical and administrative processes to improve patient safety and service efficiency. Key challenges: professional autonomy versus standardization. The core of the challenge lies in the clash between the culture of professional autonomy and the process-driven philosophy of a quality management system. Intangible outputs and measurement. While a factory can easily measure defects per million, measuring quality in healthcare is difficult. Defining and agreeing upon these metrics is a major political and technical hurdle. Lesson: this case highlights that in service and change-oriented projects, the project manager must also be a skilled change agent. The critical success factors are not found in the project schedule, but in the ability to manage stakeholder expectations. The project is not done when the system is designed, but only when it is fully embraced and utilized. Having established the fundamental definitions, context, and history of the discipline, we are now prepared to explore its core components in greater detail. This book is structured to mirror the logical progression of project work itself. Chapter 2 delves into the structural frameworks. Chapters 3 and 4 form the technical heart of project planning. Following this, Chapters 5, 6, and 7 shift focus to the human and organizational dynamics. Finally, Chapters 8, 9, and 10 address advanced competencies.